Hi class! This video is about preparation and chemical reaction of alkene. The type of reaction involved is elimination. So there are two methods to prepare alkene. First, from alcohol, dehydration of alcohol. The second one is from haloalkene, dehydrohalogenation of haloalkene. While we're forming the product, right? Sage's rule is used or is applied to deduce which one is the major product of elimination reaction. So first of all, we go for dehydration of alcohol. Involve loss of water from alcohol. So this is alcohol react with the reagent of concentrated H2SO4 sulfuric acid and heat, then it will form alkene. So for this reaction involve mechanism. Later we are going to check what is the step involved in this mechanism. Okay, the second one is involve loss of haloalkene. The X is represent fluorine, bromine, chlorine, or iodine from haloalkene. So the reagent involved is haloalkene react with potassium hydroxide. Sometimes sodium hydroxide also can, as long as it's a base in alcohol, ethanol, then reflux, it will form alkene. So what is Sage's rule? Sage's rule is the process or in elimination reaction, the alkene with more highly substituted double bond means greater number of alkyl group attached to the carbon-carbon double bond is the major and more stable product. Later we are going to check how to apply Sage's rules. So this is the mechanism involved for dehydration of alcohol. So you check the yellow one is with 3 steps and then the pink one with 4 steps. Why there are 3 steps and 4 step difference? Okay, we check one by one. So step 1, protonation of hydroxyl group or protonation of alcohol. So alcohol with the lone pair, right, go to attract the hydrogen from the sulfuric acid. And then the bond between the H and O is breaking and then form HSO4 negative. The alcohol attract the proton, now it with the charge of positive sign, okay, with the positive charge. So we call it as protonated alcohol. Step 2, formation of carbocation by eliminate water. So this one is the protonated alcohol. It will eliminate, okay, eliminate the H2O. So from the bond point to the O, oxygen atom, okay, and then remove H2O. Now it form carbocation. So when you write down the mechanism, right, please write down the class of carbocation. It can help you to determine whether this one is the stable or not stable carbocation. Okay, later we check the real example. Okay, step 4, deprotonation to form alkene. Now, the HSO4 negative that generate from the step 1 go to attract, okay, the hydrogen. Now the CH bond point to the CC bond to form carbon-carbon double bond. Alkene is formed. And then H2SO4 is regenerate. So rearrangement might happen in order to form a more stable carbocation. That's why there are some examples involve rearrangement. So total with 4 steps. So step 1 still the same, protonation of alcohol. So this alcohol, right, okay, attract the hydrogen here from the protonated alcohol, and then here from the H2O. Okay, so certain example I might use a H3O plus, but I encourage you all use H2SO4 because based on previous slide, we know the reagent that we use for dehydration of alcohol is concentrated H2SO4. But I want to show you another example, H3O plus. Okay, okay. The second step, formation of carbocation by eliminate water, still the same. Remove H2O and then form. This is what I mentioned just now. Please state the class of carbocation. This is primary carbocation. Why? Because this C only attached with one alkyl group. Sorry, suppose I should say this C attached with one carbon. That's why this one is primary carbocation. Okay, now step 3. Okay, this is extra step which involve rearrangement. Why? Because need to form a more stable carbocation. So for rearrangement, right, can be 1,2 hydride shift or 1,2 methyl shift. What is the different hydride and methyl? Hydride means the moving of hydrogen atom. Methyl means the moving of CH3. You can check from your textbook. Sure got the example about hydride or methyl shift. So in this case, this hydrogen, okay, this hydrogen is moved to C1 over here. That's why it becomes CH3. After this hydrogen move to the C1 over here, okay, it will become tertiary carboxyl ion attached with 1C, 2C, 3C. So tertiary carboxyl ion is formed. So this one is the most stable class of carboxyl ion. Okay, now step 4, deprotonation to form alkene. So in this case, right, okay, the H2O, okay, will regenerate back the H3O plus by attract the hydrogen. Okay, always remember we must take the hydrogen, okay, from the C beside the carboxyl ion. So this is the carboxyl ion, right? So I might take the C from this C, or I might take the C from this C. Okay, this one we ignore. Why? Because here is CH3 and here is CH3 is the same group. So if same group, right, will produce the same product. That's why we ignore the CH3 over here. So the first equation, I take the CH from the C1, okay, the H over here. The second example, I take the C from this one, if C1, 2, 3 from the C3. So after that, okay, we check for the first equation first. Okay, H2O attract the H over here, and then the CH bond point to the CC bond, okay, and then form carbon-carbon double bond. Okay, the second example, okay, same. Okay, use the take the H from the C3, and then CH bond point to CC bond, very important, and then form the double bond over here. Now, there are two products are formed. Which one is the major product? Okay, I circle the C double bond C so that can help you to identify the substituent. Okay, so for this one, okay, this C double bond C, one substituent, which is CH2, CH3. Second substituent is CH3. So this is di-substituted. Okay, 2-methyl, 1-butene is a di-substituted product. How about this one? C double bond C. Here 1 alkyl group CH3, 2 alkyl group CH3. Here there are 3 alkyl group CH3. Meaning that this one is tri-substituted. So for 2-methyl, 2-butene, there are tri-substituted product. Meaning that this one is the major product and 2-methyl, 1-butene is the minor product when we apply the Zajev rules. After we learn about the preparation of alkene and the dehydration of alcohol elimination mechanism, now we proceed with chemical properties of alkene. Okay, previous we learned about Zajev rules is for elimination reaction. Another new rules for this part is Markovnikov rules. Please check the spelling. This is the rules that apply in the electrophilic addition of alkene. The electrophile adds to the carbon atom of the carbon-carbon double bond with greater number of hydrogen atom. Okay, this is addition reaction. Why? From double bond becomes single bond, and then A and B atom will be added to the C double bond C becomes C single bond C. Okay, why is electrophilic? Because carbon-carbon double bond is high density area, which is nucleophilic site. So electrophile is added to the carbon-carbon double bond. Since electrophile is added, that's why the name is electrophilic addition of alkene. Okay, check. There are 1, 2, 3, 4, 5, 6. 6 types of electrophilic addition of alkene that you are going to learn now. So the first one is hydrogenation, means alkene react with hydrogen with the help of catalyst, can be PT, PT, nickel, and so on. So 2 hydrogen atom will be added. So here hydrogen added to the C double bond C. So we no need to apply the Markovnikov rules because it's the same. Okay, the second one, halogen in inert solvent. In this case is using bromine in inert solvent. If you are using chlorine, right, chlorine is in gas, that's why no need to write down CH2Cl2. But for bromine, yes. So both are the same atom, means the halogen. So this case, bromine is added to the carbon-carbon double bond, so no need to apply Markovnikov rules. Next, halogen in water. So halogen, so chlorine in water, H2O. So halogen atom and hydroxide ion will be added. Okay, in this case, we need to apply Markovnikov rules. So based on the definition, electrophile add to the C carbon-carbon with greater number of hydrogen atoms. So we check. Here is the C1. Here is the C2. Okay, you check C1 with 2 hydrogen and then C2 with 1 hydrogen, meaning that the electrophile will be added to this C. So in this case, halogen and hydroxide, which one is electrophile? The answer is halogen. So that's why Cl is added to C1 and then OH is added to C2. So this is what we call Marconi-Curve rules. Now we check for the next acidified water. So hydrogen and hydroxide will be added for the reaction for alkene with the acidified water. So for sure, hydrogen is the electrophile. That's why hydrogen added to the C1 and then OH added to the C2. Okay, for this acidified water, right, we are going to learn the mechanism later, mechanism 4. And then this one, hydrogen halide, we need to learn the mechanism as well. So for hydrogen halide, okay, hydrogen and halide ion will be added. So in this case, hydrogen is the electrophile. That's why added to the C1 and then chlorine added to the C2. Okay, next, why there are two hydrogen halide? Because you check, peroxide is involved in this reaction or anything with ROOR. What means by ROR? It can be CH3, okay, OOCH3. If you notice, right, when you want to solve the problem related with electrophilic addition and then there are hydrogen peroxide or anything with ROOR, you have to take note. This one is anti-Marconi-Curve rules. Okay, what means by anti-Marconi-Curve rules? Meaning that, okay, this case, hydrogen and chlorine. Hydrogen won't be added to the carbon with greater number of hydrogen because anti. That's why hydrogen will be added to C2 and then chlorine added to C1. So this function of hydrogen peroxide is not follow Marconi-Curve rules. The purpose you can check, try to check what is the real purpose of hydrogen peroxide in this case. But this reagent will not allow you to apply Marconi-Curve rules. Now this is the third mechanism in chapter 5 hydrocarbon, electrophilic addition of hydrogen bromide. Okay, so step 1 involves the formation of carbocation ion and halide ion. So first of all, right, we must know the HX, X is referred to halogen, is a polar bond. Okay, so hydrogen is partially positive and then halide ion is partially negative. So the breaking of the bond, right, will form the H+, which is the electrophile, and halide ion. So the electrophile is attacked. Okay, here the carbon-carbon double bond is high electron density, which is a nucleophilic site. Okay, so it's attacked by the pi electron of the double bond to form carbocation ion. So it's attack means attract the hydrogen and then over here and then here forming the carbocation ion. Okay, so now the hydrogen is added to double bond which is high with high or greater number of hydrogen atom. Okay, since this one is general, never mind, we just proceed. Okay, now step 2, formation of haloalkene. So the halo ion donate electron pair to carbocation ion. One is donate the lone pair for the carbocation ion. Now it forms haloalkene, which is a fast step. Okay, a new CX bond is formed when bromine or halide ion donate an electron pair to the carbocation ion and haloalkene is formed. Why there are 3 steps for this side? Because rearrangement might happen in order to form a more stable carbocation ion. Again, carbon-carbon double bond, this is the pi electron of the double bond. Okay, attack the hydrogen or attract the hydrogen, okay, forming the secondary carbocation ion. And then at the same time, the HBr bond is breaking, which is a slow step, from the halide ion. So in this case, it is bromide ion. As I mentioned before, must always state the class of carbocation ion form. So this one is the secondary carbocation ion. Okay, we will try to rearrange to form a more stable carbocation ion. So in this case, the hydrogen over here, okay, can shift it to this carbocation ion and then form a new carbocation ion, which is a tertiary carbocation ion, a more stable carbocation ion. So this reaction we call it as 1,2 hydride shift because the hydrogen is shifted to the next carbon. Of course, there is another one is 1,2 methyl shift, means the CH3 molecule is shifted to the next carbon. Here. So since form the tertiary carboxyl ion, we can continue for step 3. The halide ion donate electron pair to carboxyl ion in order to form a haloalkene. So in this case, it's a fast step. The bromide ion, okay, is donate a lone pair to this tertiary carboxyl ion and then form the major product. If we didn't doing the rearrangement right, okay, if we stick to the first one, okay, this one will form the minor product. Don't forget for the fast step. Write down the fast for the step 2 or step 3. And then the step 1 with the slow step. Here. Next, we go to mechanism 4 in this chapter, which is electrophilic addition of acidified water. So step 1, formation of carboxyl ion. Again, carbon-carbon double bond is the high electron density area, which is nucleophilic site. So the electrophile H3O plus is attacked by the pi electron of the double bond to form carboxyl ion. So H plus ion is added to the double bond according to Markovnikov rules. So and we check this is a tertiary carboxyl ion, which means this is the most stable carboxyl ion. Step 2, addition of water to form protonated alcohol. So H2O is added to the carboxyl ion and then forming the protonated alcohol. Remember, must write down the positive charge on the oxygen atom. Now we move to step 3, elimination of H+. So in this case, deprotonation occurs to remove the hydrogen to form alcohol. So the H2O from here, actually there is a byproduct over here plus H2O. So the H2O from the step 1 proceed or continue, okay, its function to attract the hydrogen to form back the H3O+. Okay, now 2-methyl-2-propanol is formed. Okay, if you look at the step 1, step 2, step 3, step 4 for this reaction, there is an extra step because rearrangement happened. So step 1 still the same formation of carboxyl ion. So the carbon-carbon double bond over here, okay, so the electrophile H3O plus ion is attacked by the pi electron from the carbon-carbon double bond, and then here bond breaking, forming the secondary carboxyl ion and H2O. So now, second step, rearrange to form a more stable carboxyl ion because this hydrogen can move to the next carbon, so form CH2. And then now this is new carboxyl ion, which is a tertiary carboxyl ion after the 1,2 hydride shift happened. Okay. Step 3, addition of water to form protonated alcohol. So this water is added to the carboxyl ion and then form a protonated alcohol with the positive charge on the oxygen atom. So the last step, still the same, eliminate the H plus ion. Okay, deprotonation happen to remove the H plus. Okay, and then the bond breaking between the O and H mixture pointed to the oxygen. Now it formed the alcohol. And H3O plus is regenerated. Next is the reaction about oxidative cleavage of alkene, which involve ozonolysis and hot acidify CmNO4. The purpose of these two reactions is to identify the position of carbon-carbon double bond, meaning that first of all you must know after the bond breaking what is the product or what are the product will be formed. At the same time, when the product is given, right, you must know how to join it back and then check for the reactants. So let's check one by one. So the first one, ozonolysis. The reactants involved are alkane and ozone. Then the product is aldehyde and or ketone. So the reagent for ozonolysis is O3 ozone followed by zinc water, or O3 followed by dimethyl sulfate. So normally I will guide my student, right, when the carbon-carbon double bond is given, right, we have to break the bond. Break the carbon-carbon double bond and then form C double bond O at both sides. Here C double bond O, here also the same C double bond O. Okay, that's all. Okay, we check. This is the part 1. After it formed the C double bond O, okay, since there are two alkyl group, ketone is formed. Okay, the second part, Okay, still the same, from the C double bond O, you just copy everything, the CRH, you just copy, and then aldehyde is formed. So this is what happened in ozonolysis and what type of product will be formed, ketone and aldehyde. If there is H, aldehyde. If there is no hydrogen, only remain the alkyl group, then is ketone. Okay, next, hot acidified KMnO4. So the symbol for KMnO4 is KMnO4 bracket H plus, means the H plus is referred to as acidified, and then normally the heat will represent like this. It's a triangle sign. Okay, for this case, the reactant involved are alkene and hot acidified KMnO4. The product that might be formed is ketone and or carboxylic acid or carbon dioxide and water. Please take note, for this reaction, aldehyde won't be formed. Check for the first one. As usual, need to break the bond. Break the C double bond C and then form C double bond O as usual. And then here form the C double bond O as usual. But you check, in this case, CH2 is formed. When CH2 is formed, right, okay, the product for this reaction is carbon dioxide and water. Please take note, when CH2 is formed after the cleavage of the C double bond C, when using hot acidified KMnO4, the product are CO2 and H2O. Now we go for the second part, for this part. Okay, still the same, from the C double bond O, and then the Cr still the same, but please take note, when there is hydrogen, the reaction will continue, oxidize, become OH. Then C double bond O OH is formed. So carboxylic acid is formed for this case. Okay, now we proceed for the next. Still the same, break the bond, and then it will form the C double bond O, C double bond O in this case. So for this side, you just copy everything. There's no hydrogen, so just copy. So Cr, R, so ketone is formed. Okay, for the second part, right, after you form the C double bond O, you check there is hydrogen. So hydrogen will continue oxidize, form OH, carboxylic acid is formed. So if compared with ozonolysis much more easier. You just break the bond and then form C double bond O, C double bond O, the rest you just copy and paste. But for hot acidified KMnO4, be careful. CH2 form CO2, H2O. If after break the bond, right, the C double bond O with one hydrogen, right, it will form the carboxylic acid. If there's no hydrogen, like this case, the yellow and pink are, you just copy and paste everything and then form ketone. Next is about chemical test of alkene. There are 3 tests are used to identify alkene. The first one is Bayer test. Okay. Second, reaction with bromine in inert solvent. These 2 is exactly same as your practical test or experiment 4. Okay. We are using the reagent dilute KMnO4 basic. Okay, so this is using dilute KMnO4 in basic medium, and then the condition is cold. Totally different with the oxidation test just now. Don't be confused. This one we call as Bayer test. So the way to write down the reagent is like this: dilute KMnO4 / OH negative cold, and then it will form diol. Okay, actually this is one of the electrophilic addition as well, because from double bond becomes single bond, and MnO2 precipitate. So the observation is purple color of the KMnO4 solution decolorized and brown precipitate of MnO2 is formed. Okay, the second one, reaction with bromine in inert solvent. So bromine in inert solvent, condition dark. Okay, actually no matter dark or under sunlight, okay, it will give the same product, which is 1,2-dibromocyclohexene. Okay, the reddish brown color of bromine solution decolorized. But when you want to compare cycloalkane ANE with cycloalkene ENE, right? So the condition is very important, because under dark condition, only cyclohexene ENE will give the positive result. But cyclohexane ANE, the reddish brown color of bromine solution remain the same. Okay, that's why here I put a dark. If you are using bromine in inert solvent to compare with others product, for example, you want to compare with carbonyl, alcohol, okay, the condition, no matter dark or UV, still will give the same result. Because for alcohol or carbonyl, right, they won't give any reaction for this bromine in inert solvent. Okay, the third one, reaction with bromine in water. Okay, so there's no special condition. So the observation is yellowish brown color of bromine solution decolorized. Okay, always remember this is actually is electrophilic addition. So the atom that will be added is hydroxide and bromine. So the famous one is Bayer and reaction with bromine in inert solvent. Please take note for these two chemical tests of alkene. That's all for this video. Thanks for watching. Please don't forget to subscribe, like and share. See you all on next video. Bye.